Hi there, you've made it to the last video, congratulations, and this time we're talking about the half-life formula, which you're going to want to copy down on your sheet there. Let me just talk to you a little bit about this. This says A equals A sub 0 times 1/2 to the t divided by h power. The A is your ending amount, your A sub 0 is your initial amount, how much you start with, and t is time, h is half-life. So normally you're going to use this formula any time that you know how long it takes something to be cut in half. So it could be, usually we're talking about radioactive isotopes. We know the half-lives of most of those. But other times, it could be populations, if you know how long it's going to take a population of something to be cut in half. It could be anything. But one important note that I want you to make note of here is that t and h need to be in the same unit. So you don't want to be talking about t in days and your half-life in years, or your amount of time in hours when your half-life is in years. So make sure that your t and h are in the same units. So let me show you how to solve a few of these. Bananas, and this is true by the way, bananas contain the radioactive isotope potassium-40. Don't worry, it's not harmful, but it's true. Bananas contain radioactive isotope potassium-40. Potassium-40 decays with a half-life of 1.25 billion years. A. Write an equation to model the amount of a 40-gram sample of potassium-40 remaining after t billion years. So let's write the equation here. A is the final amount, which I don't know. So I'll just put it, equals A sub 0, the initial amount. In this case, we're talking about a 40-gram sample, times 1/2 to the t divided by h power. Now I don't know t, so I'm just going to put that lowercase t, and I'm going to divide it by h, the half-life, which is 1.25 billion years. That is the equation for calculating the half-life, and that's all you need. Now, I only wrote 1.25 because I know that t is in billions of years. If I thought t was just in years, then I'd write 1.25, and then I put a bunch of zeros for billion. So that is the equation. The part B, how long will it take for 175 grams of potassium-40 to decay to 50 grams? Let me show you how to solve that. So the formula to figure out how long it will take is going to be, well, let's just write down the formula. A equals A sub 0 times 1/2 to the t divided by h power. Now we know some of these things. We know that the ending amount is going to be 50 grams. We want to know how long it's going to take it to get to 50 grams. So I'm going to write the 50 right there. And I'm starting with 175 grams. I know the 1/2. And the thing I don't know is the amount of time, so I'm just going to put a t. But I do know that the half-life is 1.25 billion years. And again, I'm going to use a 1.25 there, keeping in mind that my answer t is going to be in billions of years. It's going to spit out a number, but I'm going to have to write billions of years. Otherwise, you would, if you just kept this in years, you'd have to write out 1.25 billion, which is a long number that I don't want to write. So the first step here to get this t by itself is to divide by 175 on both sides. And I've got a calculator to help me cheat here. 50 divided by 175 is, let's keep that as a fraction, 2/7 equals 1/2 to the t divided by 1.25 power. At this point, we are going to want to use our log rules. Don't forget, this is way back in the first video there. Y equals b to the power of x, and log base b of y equals x. I'm going to rewrite this equation right here as a logarithm. So log, the base is 1/2, so log of base 1/2 of 2/7 equals the exponent up here. t divided by 1.25. Well, remember, we're trying to get the t by itself, and currently it's divided by 1.25. So I'm going to need to multiply both sides by 1.25. So I'm going to go ahead and do that right now. And so I'm going to have this monstrous looking thing, 1.25 times log 1/2 2/7. And that equals t. But now we're going to need to do the little change of base formula in order to get the be able to type this in the calculator, because there's no log 1/2 button on your calculator. You got to do the change of base. And remember, that rule is log of b divided by log of, log of a divided by log of b. So we're going to do log of 2/7 divided by log of 1/2. That's what we're going to type in the calculator. And as you can see, there's an awful lot of parentheses here, so we're going to have to be very careful when we're typing this in the calculator. Let me show you exactly how I want you to do that. So we've got 1.25 times log of 2/7, close the parentheses, divided by log of 1/2, double close the parentheses. So be very careful with your parentheses when you're typing this in calculator, otherwise you'll get the wrong answer. But when I hit enter, I get a number that's pretty close to 2.26. So t equals 2.26, which makes sense because for this thing to split in half, it takes 1.25 billion years. So 50 would be more than half. So if it takes 1.25 billion years to cut it in half, we'd expect it to be greater than 1.25. But I've forgotten one thing here. I've forgotten to put my units, which is billions of years. The amount of time for it to go from 175 grams to 50 would be 2.26 billion years. All right, thanks for watching, and we'll see you next time.